welcome to Unapologetically Technical. My name is Jesse Anderson, and this is the show that's different. This is different because we go deep, we go all the way down. We are going to be talking in depth about various parts of streaming and a company called Streambased. With me today is Tom Scott. He's the founder and CEO of Streambased. Would you mind introducing yourself a bit more, Tom?
It's a pleasure. Thanks for having me, Jesse. As Jesse says, I'm founder and CEO of Streambased, a company that performs analytical operations on longer-term event streams. I would say I'm a distributed systems engineer rather than a data engineer per se. I've worked across compute grids, across big data systems, and I'm very heavily into event streaming systems right now.
Excellent. And that's an interesting distinction because I would say that my distinction as well. I would say I'm a distributed systems engineer first and then a data engineer second. So what makes you make that distinction?
So that's very interesting. I think we're of a certain generation. I think maybe both of us. So that's why we're able to make that distinction. So I started my career in financial services, particularly in pricing financial products. And that was a very, at that time, distributed systems problem rather than a data problem. So we would take small input data and run very, very highly parallel simulations in order to achieve a result that would then be a very small amount of data as a result, but in most cases was recorded and then any interim steps or any interim results thrown away. So I would class that as a distributed systems problem. And the kind of technologies that we were working on, I don't know if you're old enough to remember TIBCO grid server and things like that, were were very much biased towards the compute side. Now, I can actually place the exact moment where that philosophy changed for me. It's quite interesting because it coincides with my son being born. I was working at an investment bank doing credit default swap pricing, back in 2009, post credit crunch. There was quite a lot of that going on. And my son was due to be born the next week. So I worked for a consultancy at the time. Actually, I noticed you had Neil Overy on before. We both worked at the same consultancy at Excellion. Me and Neil follow each. We never worked directly together, but we followed each other's careers quite closely. It's an interesting, small world, I guess.
Uh,
Um,
That's interesting. Continue.
so I was all ready to go on paternity leave, but my son wasn't ready to arrive yet. So I ended up with 2 weeks where my contract with the client had ended, and I was back at the consultancy head office looking for something to do. Now, the consultancy at the time was heavily into Microsoft Azure back in the early days, and I was heavily into this new fangled thing called Hadoop that was just starting out. So I was tasked with doing a proof of concept of bringing Hadoop into Azure, something that seems trivial these days, but that actually hadn't been done at that point. And it would have been what, CDH3? I know you're an ex-Cloudera, so you know how far back that goes.
Yeah.
Um, and the actual POC itself wasn't all that interesting. There were limitations in Azure in those days around locking images when you're starting VMs that meant it was never going to be practical to launch 30 data nodes at the same time. But by the time I'd finished with that POC, I was itching to get into the big data world. So really, after that point, after it was MapReduce, I guess, MapReduce and HDFS that turned me from a distributed systems engineer into a data engineer.
So that's interesting because I still see you're talking about simulations, Monte Carlo simulations, for example. I still see those as big data because I see them as big data because of the sheer amount of data that you're going to have to work on, not output or input necessarily, but within those being within that seam. And I don't know if you ever saw the Million Monkeys project I did, where I randomly recreated Hadoop with, or randomly recreated Shakespeare with Hadoop, where if you divided up the problem in this case on mappers, you could use something like Hadoop to do a distributed systems simulation without having to write a bunch of simulation code and a bunch of harness for that, or grid as we would have called it then.
Yeah, totally. And it's funny you should mention that because the very next project I did for the consultancy was exactly that. So we put a small amount of, it was a Monte Carlo simulation. We put a small amount of input data in and then ran it in EMR to just scale it massively across AWS on spot instances for very small amounts of time as a batch process. But then what do you do with the interim data? At that point, I'm sorry to say, we did just throw it away. Pull down the instance, shut down the cluster, pull down the instances, and threw it away. But um, things have moved on a bit now, I think, and that would be a horrific thing to do these days.
It would be, but we have to have this progression. I think that, yeah, I mean, we were talking about CDH3. That was really back in the day. That was quite a while ago. And I think we have to have this progression um, to understand it. Part of me worries that the newer people aren't going to have to hit these problems, or they won't understand why you hit the problems. But or even for that matter, the difference between distributed system engineers. Like we think about the problem. One thing I like to tell people is there's a difference in a type of question that you ask of as people move from, let's say, software engineering into big data. They ask, what's a distributed system? Whereas a distributed systems engineer asks the question, how is this distributed system different from this one? And the two are very different. One's a lateral question, and the other one, the one of the software engineer or the DBA or whatever, that's a significant step up. But if you're asking how is this distributed system different from another, you're asking, I already understand distributed systems. How does MapReduce work differently than other distributed systems, for example?
Yeah, and it's you mentioned the progression, and we'll get onto it at the moment. But I think um, it's very exciting. Recently, I think the progressions that we are seeing, it's almost like a fan out. We're seeing progressions in many different directions in many different areas, and it's just a really exciting time to be a distributed systems engineer.
So you were talking about those examples where Monte Carlo simulations, you could say that they're kind of real time, kind of batch, but I would say they more skew towards batch. What makes you so interested in real time now?
Well, I'm actually going to say something controversial. It's
Please.
not necessarily real time or some of the definitions of real time that interest me. So, what really interests me is event driven architectures. Um, the whole concept of using event driven principles in order to guide your systems and your decision making really, really thrills me. And it has done since the early days of Kafka, all the way through to the more complex stream processing and analytics that we're doing right now. As a concept, as and as a data engineer, I always had you get that feeling in your stomach every time you overwrite and update a value, but you go, okay, there's my history lost, right? And that and those kind of systems and architectures were common, and we'll come back to that in skybetting and gaming, I think. But the nature of um, event-driven principles and event-driven systems, I think, is really exciting in terms of the scope of benefits that it can offer to customers, internally, to engineers, just across the board.
That's interesting. The event driven architecture being very important. I was doing an interview the other day with somebody, a job interview, and they were saying, "Oh yeah, we're using Kafka." And I said, "Well, what are you using Kafka for?" They said to put it in the database so that something else can pull for an update. And I thought, "Oh my goodness, did you completely miss the point of pub sub systems? This is uh, my mind was
Well,
blown."
this is interesting, right? Because back in the day, NiFi thrilled me for what it offered in terms of event-driven systems. Kafka Connect still thrills me every day. I love the kind of effects of breaking up a problem into events that have occurred and then reassembling them in the destination system where it can be useful. This approach just it makes me excited. You can probably tell.
Oh, yes. It's palpable. So let's talk a little bit more about your next thing, that was Sky Betting and Gaming. And you were building a data warehouse, you were leading a team there. What does a betting data warehouse look like?
So I was actually shocked when I started at Sky Betting and Gaming. I came from this investment bank, this financial background, and I treated gaming as like just a different kind of financial product. I went in there expecting them to price the entire market. I went in there expecting really solid, consistent market data sources, and expecting the same kind of things that you see in financial services. It's very, very different. So, what we actually did in Sky Betting and Gaming was we were migrating from an Oracle data warehouse that had stood the test of time, but wasn't ready to provide the kind of analysis and the kind of capabilities that you'd expect from a big data system. And we were migrating that to a Hadoop based, I think it was CDH5 um, data warehouse. And it was that difference in capabilities, if you can think, between a mostly sort of personal driven, I want to say. Um, let's try and use some concrete examples. A lot of the betting industry doesn't price their own products. They just use the prices from other people in the industry to make sure they're consistent before. And Sky Betting and Gaming wanted to move away from that practice and give themselves the ability to price their entire product set, and using distributed processing frameworks in order to be able to do that. And an Oracle data warehouse, I'm not going to say wasn't going to be capable of doing that, but wasn't going to be capable of doing that easily and flexibly. So what we were looking at Sky Betting and Gaming was a migration from a short-term store, the Oracle data warehouse, to a much, much longer-term store in a Hadoop.
So let's rewind. One of the important parts, I'm actually hitting this with another client right now and talking about. I come from that financial industry too. We have very clear deltas, we have very clear Greeks on that, we have all this data. And then I started peeking into these sports betting places, and I don't know, did they not? For some reason, it seems like they didn't say, let's go hire people who did this in the financial world and we'll put them in there. And it seems like they're just taking, not understanding that and putting random people in there, random non-distributed systems engineers in there. It's kind of weird. So you were able to peek in there, see what that data looked like, and what sort of insights did you gain from that data as a result of cleaning this up?
So while I was there, one of the things we did was we actually built out a data science team. We went up to, I don't remember which university it was, but we went and hired data scientists, graduates, and built that function out, which has been enormously successful with the business. Now, it wasn't necessarily as successful in the product profiling, but it was very successful in the customer profiling. And one of the core values in Sky Betting and Gaming was that, detect when people have a problem and they need, and kind of remove the tools to avoid people getting themselves into real trouble with gambling. It's well publicized, it's easy to do, and Sky Betting and Gaming really wanted to be a best of breed actor in that case. So, in order to be able to do that, we built out much more detailed customer 360s that were available because we were able to ingest a much larger variety of unstructured data into the Hadoop cluster and work on it in a way that was very different from the way that people operated with the old Oracle cluster. And I really think those kind of big data cases were the textbook big data cases. And they're great in some ways. And you may disagree. I think quite a few people disagree, and it's okay to disagree. But I think the unstructured cases were where big data absolutely shine, and it's kind of lost some of that sheen in recently. So Yeah, a lot of people employed big data to replace very structured, very normal data warehouses, and yeah, a lot of the time they were capable of doing all of that stuff to begin with. Where you really got the bang for your buck out of Hadoop was when you had a very strange or unusual data source that you were suddenly able to process and able to gain value from, and it's a value that your competitor um, or your regulator couldn't see just by looking at the data set in design. It's an exploratory data analysis problem. Let's say that.
So there's two interesting parts to that. I want to go back to one that you were talking about before of the people having gaming problems, gambling problems. If you walk around a casino in the United States in Nevada, there's a lot of posters up saying, if you have a gambling problem, here's Gamblers Anonymous. So I'm curious, from your data, how were you finding gamblers or people with problems? Was it looking at straight loss? How are you finding that?
So I'm not a data scientist, so I could give you my take on it, but it's
Please.
probably completely wrong, and I'll get a phone call after this saying, "What on earth were you saying?" But I think a lot of it is around pattern matching. Right? You look at the ways in which people play a sudden jump in volume, unusual timings, sudden jump in stake, sudden jump in the variety of products that they are using, and it's identifying those kind of things. Um, I don't. What's interesting is they do have a large Kafka presence in Sky Betting and Gaming, and I'm pretty sure they're doing that kind of stuff in real time now.
Okay. And then there was the second part that you were talking about of unstructured data. And I would agree with you there. There's two parts to big data. I think there's the structured and then there's the unstructured. What I always worried about with the unstructured is people who had structured data that then said, okay, let's make it unstructured because we can't put a schema in there and we can't figure this out. Let's just make it unstructured. I think that was just kind of rolling over and playing dead and not really attacking a hard problem. But when you're dealing with truly unstructured data, yeah, it did great. There was some pretty cool things that you could do that were basically impossible before.
Yeah, and I agree with you. Schema on read is still evil, right? It's still evil. It's it was useful for certain types of unstructured data, but I think one of the worst things Hive ever did was apply it across everything in the world. Certain things have natural schemas, and they don't like you shouldn't really be able to change that just because you feel like it on the read. Just leads to massive consistency problems.
And you were leading the team there. Tell me more about some of the challenges that you faced leading that team.
Sure. So I'll talk. One of the major challenges that we focused is just being covered and buried in grunt work. So because we were a migration, there was all sorts of, and also a new capability. Uh, I would say 80% of my team spent 90% of their days building new pipelines and maintaining old pipelines or extending pipelines. That's what they did for their time. Um, and there were various technologies and approaches that we implemented to address that. One of which was a Ruby DSL language that was named Piddle, which is which was quite nice. A sort of high speed way to um, build pipelines in a very fast way. But I would say in some ways that hurt us rather than helped us because we spent our time trying to extend Piddle to do the stuff that we could do previously in a flash. It's a big problem, and it's one that I think only really with recent sort of data mesh principles have we really addressed that data engineers shouldn't necessarily just be building pipelines all day long. I'd rather they were focused on the efficiency and new capabilities of the data systems that they own, rather than just doing what I call this grunt work of getting data set A over to system B. But
And I think a lot of people watching this will be in the same sort of boat as you, or that team was of legacy system trying to be displaced. What single piece of advice would you give them that would be help them the most?
I'd say focus on self-serve as like a core value. Um, if you take a team culture and say, my value as a team is in providing tooling for people outside of my team to work, it's a very sort of data meshy principle, actually, to be honest. Right? And take that as a core cultural concept of your team, then you will save yourself a lot of work in the long run. And actually, I'm not even going to say that. You may not save yourself a lot of work in the long run, but you will find yourself happier and more fulfilled. And that makes better data engineers.
It does. So from there, you went and you pivoted. You went to Cloudera. You and I didn't cross over. I had left already by the time you were at Cloudera. But you did something different. You went from being a distributed systems data engineer to a customer operations engineer. Why did you do that?
So actually, there's a couple of previous ones where I've been a customer operations engineer as well in my early days. But I have very, very strong opinions on this subject. If you want to get breadth and depth, you want to be a customer operations engineer. Pure engineers end up specialized. It's what they do. And there's a reason for that. And it's good practice to become specialized in that way. But if you want to be able to see your company, take Cloudera at its peak, it had what, 48 products or something ridiculous like that. If you want to be able to see the whole breadth of the value that you're attempting to add from your distributed systems or data company, then customer operations engineer, that's the best way to see it. So that's what I wanted to do with the move to Cloudera. I wanted to be able to see the big data movement as a whole. I wanted to be able to see how each of the Cloudera products was addressing different problems and to be able to get skilled up on the ways in which they do that. And actually, I wanted to talk to the customers that were experiencing these problems. And I think a lot of the future, we'll talk about the entrepreneurship and things like that later, is driven by this need to be able to understand the problems that a customer is facing at a day-to-day level, more than just at a here's some requirements that came across from products based on some conversations and things like that. I think it's a really powerful thing. And it's interesting that there is a merge that's kind of happened recently. This kind of differentiation between core engineering and customer operations engineering has kind of been broken down a bit. I feel like the ops engineers that I'm still talking to are now contributing significantly to the design of features, if not implementing the actual code. Uh, and I feel like the core engineering teams that I'm talking to are spending more and more time on call, spending more and more time directly facing customers when they're having issues, in order to understand their product set better and what they can do to improve that customer experience.
So that's interesting. To just be very clear, you're saying at Cloudera, you weren't just a customer facing doing tickets. Hey, you have this problem with Hadoop, reboot that. You were doing that and doing some coding on that. Is that correct? On the actual
Uh,
products.
no, not at Cloudera, no. that,
No.
that comes later in life. So at Cloudera, I was doing tickets and then I was coding in my spare time to make the
Oh,
figure out how things
to scratch that itch.
Yeah, yes, exactly. But I
Okay.
think that's changed we're going back 10 years now. And I think that sort of concept has changed now. The COEs that I know today are, if not necessarily coding, they are definitely contributing to design and helping core engineering understand the problems.
So let's expand that out. How do you think COE or customer operations engineer makes you build a better product?
I think when you build and it's necessary in order to achieve anything in an engineering project, but when you build something from scratch, what you do is you look at a set of core cases, and there's always going to be this middle ground, right, where you look at the core cases that you want to address, your Pareto 80%, this kind of thing, and then you build a product that addresses those. What's interesting about customer operations is that it focuses on that other 20%. You're going to be speaking to um, almost for the majority of your time, if not like close to 50%, right? You're going to be talking to customers that have this weird problem, right? This thing that happened because they tried to use something in a different way, or um, they tried to throw a volume at it that you weren't used to, or they tried to partition it in a different way, and you get that exposure to what happens when the system is stretched, if you know what I mean. You step out of that middle ground. And I think the insights from outside that middle ground are very, very important in progressing the project. It's a somewhat ignored thing these days, to be honest. I think that the uh, the exceptional scenarios are actually very, very useful data points. Um,
Uh,
let's think of a good example. So, like, well, let's take Netflix and Kafka, right? Netflix hammer Kafka with a truly, truly exceptional set of scenarios. But the insights that they gain from doing that really help the mom and pop small Kafka shops and things like that. It's that kind of process, but it's happening within a company and within the two sort of sides of a company's operations.
So I have a theory on this, and that is most products don't seem to be developed from a consumer point of view. They're developed, I should say, within the big data industry. They're developed first and foremost from a developer point of view, the person who's writing it, that is. And I'm wondering if that's one of our main problems. When we could talk about Kafka in this case, for example, early Kafka code was very developer focused instead of what is the best API that would make it the easiest for somebody to write some Kafka code. I don't know if you remember the '08 3 days or the '08 2 days, pretty early on, your Kafka code was pretty ugly. And there was never this thought of, okay, let's make it as easy as possible for the clients to be able to write their code. And so if you're on the customer side of that, I think that helps you reverse that dynamic. And in the military, they call that turn the map around. So you think about it from the enemy's point of view or your user's point of view. And I think we could do significantly better with our products if we just turned that map around and said, okay, I want to start with what the code looks like for them, for the user, rather than let me make the easiest thing for me.
Yeah, and if we take Kafka as an example, right, the legacy of not doing that is painful. You look at the consumer APIs that we have to stick with today. Some of them are very, very painful, and it's just so hard to remove them because, as you say, they were thought about from that developer point of view, not from a customer point of view. And it creates this legacy commitment that you then have to that you carry on for the next 5, 6, 7 years, and you have to maintain.
Okay. And then you from Cloudera, you went to Confluent, and you initially started as the customer operations engineer there. What sorts of what did you make that transition from Cloudera to Confluent?
So with Cloudera, I was lucky enough to go through the IPO. Cloudera had gone public, and I was in an interesting position. The next place for me to go in Cloudera, I was very, very comfortable with what I was doing as a customer operations engineer, was to an engineering role. But due to geographical limitations and company process limitations, no such role was really available to me within the company. So I made the decision for at the time Confluent came to look for me. I didn't go look. I didn't go looking for them. And at the time, it was like, well, you can stay here and grind so much. I don't want to say grind. It was still interesting and it was still exciting, but I felt like I wasn't pushing myself in the way that I was previous.
It'd be a
Um,
grind upward. I face the same thing. I'll share that in a second.
so yes, I could face out that one, or I could go in a lateral move to the same customer operations engineering thing, but in an exciting new technology where I would get the opportunity to push myself. And I could already see how fast Kafka was moving and its trajectory, so I knew it was going to be a very exciting and interesting new challenge.
Okay. So let me share a story I don't think I've ever told before, and that is why I left Cloudera. Because but before I share that story, this is important to people watching, especially managers. If you're missing out on good people, because you're not allowing them to work remotely, even at Bay Area companies, Cloudera like that, they're still wanting all the engineers there in the same place, and they're missing out, unfortunately. And it is unfortunate because there's also a Bay Area sort of fixation, let's put it nicely, with the best people live in the Bay Area in San Francisco or San Jose or wherever, and that just isn't true. I faced that. The my story is that I faced the same thing. I was at Cloudera. I was wanting to move up, and they said, "Well, you have to live here if you're going to move up." And I said, "No, thank you. I don't want to live in the Bay Area." I was in Nevada at the time, and I didn't want to move. I didn't want to move my kids, and so you're either faced with kind of what you said, a grind where you grind where you are and have to figure out some way to move up while working remote, or you have to find a new company. And that was what I did. I started my company, and I guess the rest is history there. But the overall point I really want people to understand is just because somebody doesn't live in the Bay Area doesn't mean they're not a good programmer, a good engineer, good whatever. And that these companies that are remote first are going to gobble up your really good people. So do be careful there.
Very interesting that you say that. I know a lot of other Kafka alumni that share the same story. Confluent, Cloudera alumni, sorry.
Yeah, yeah. So now if you look at some of the Cloudera alumni's second companies or third companies, they're remote first. Like you have Eric Sammer's Decodable. It's all remote, wherever the people are. He's got a team around the world. He's got Gunnar in Germany. He's got people all over. Uh, I think I think that you can do effective remote work. In fact, if you see it behind me, one of the books back there is called Effective Remote Work. I was one of the reviewers for it and wrote a post on Harvard Business Review about how to do this. You can do this. Okay, well, coming back to technology, let's talk about what sorts of things did you learn about operating Kafka? In fact, you kind of mentioned Netflix a bit. You probably can't share those stories, but what did you learn about operating Kafka?
So operating Kafka, I was in from the very early days. So when Confluent was well, the thing I can share is when Confluent was UK was a tiny little office, not a lot bigger than this room above a paper shop. Those were interesting days. So Kafka was moving at a pace, and it didn't have a lot of the features that you take for granted from a distributed system today. I can literally remember the days when we brought SSL encryption for interbroker lists into Kafka. Like, something that you would think would be an absolutely core feature, but I can remember that being added and being adopted. So what was interesting about the early days of Confluent is that I think one thing that Confluent did really, really well was they targeted their marketing and their sales to those forward-looking and very, very sort of developer experienced companies, so that you were working with people that were interested in solving these kind of problems rather than just flipping it round and saying, you should have this, when am I going to get it? It's a nice feature of small companies. It's actually something we're trying to replicate at Streambased, that if you can find more of a partner than a customer, you can provide enormous benefits on both sides of that. And I think Confluent did that very, very effectively. So I gained a relationship with a lot of these companies that I still maintain quite a lot of them today, where we would be, they would file a ticket or we'd jump on a call or something to figure something out, and they go, "Oh, you were working on X last week, and this is the result. We need this in order to provide that feature." And we'd really develop a strong relationship with the customers. So that was I think Cloudera was a bit bigger by the time I got to that side. So it was the first time I'd really encountered this early stage in this kind of process, and it was brilliant. I absolutely loved every second of it. So in terms of challenges, we were looking at new features from Kafka and how to adopt them. And we were really writing the book on what the best practice for your business was because there weren't the references there to see. And the other thing was, how should you scale your Kafka cluster? And that remains an open question for today. But we did have lots of companies that would come from the big data world and go, right, I need 100 Kafka nodes in straight away because we might scale to that one day. Or the companies that go, right, every single key is a partition. Boy, do we have a lot of those. And suddenly we've got 100,000 partitions on a 3 node cluster and things like that. It was great because we were determining what would become the best principles for Kafka that we could then communicate to future customers and grow it into the sort of behemoth it's become. Sort of 8 out of 10 companies are now using Kafka, and yeah, there are good guidelines everywhere for doing that. But we were establishing those back in the day. It was very, very exciting time.
I don't know if you know this, but I worked with Confluent pretty early on, all the way back to when they were in the dentist office in San Jose. So that was the 5 people in a dentist office story. So I wrote their training, did their so in many ways we were on doing the same thing of here's this thing that's pretty new, and it's completely funny thinking about it that Kafka didn't even have encryption, which is
I know you just
people
you don't think about it these days.
yeah, people would ask that in the class, and they'd say, "Well, what about encryption or what about credentials and this sort of thing?" And I'm like, sorry, uh, and it's kind of funny because if you look back how it was used or the way that some of the Bay Area companies work is LinkedIn, they're not so much worried about locking down the data, and they're not thinking about the encryption because it's all within their firewall. And then you come out to the rest of the world and the banks and such, and they're thinking, we need this, we need this, we need this. And yeah, you're right. It was a lot of trying to figure out the best practices at the same time as people were using it.
It's a good example of what we were talking about previously. Kafka was developed for a very specific case inside LinkedIn without really talking to that external customer. I mean, why would they, right? They're developing a product for those guys to use. But you can see the commitments that are made that you then have to live with as you come outside. And I think it's a feature of a lot of open source projects. It's great that we develop these things to solve a problem within our organizations and then open them up to the world. But because you've done that way, it's back to your map analogy, right? Because you've done it from that side of the map rather than turning the map around, there's a lot of commitment that makes it a lot harder to be adopted by, say, less forward-looking tech companies.
So from customer operations engineer, you went into software engineering. Why did you do that?
So I became specialized. So my focus was always on kind of inter-cluster replication of data. And I became hyper-focused on that as a customer operations engineer. I think there was like one time where if there was a ticket that involved Confluent Replicator, which was their inter-cluster replication tooling at the time, there was like a 9 out of 10 chance that I was working on it. So I became very, very specialized. And well, at the time, you probably had the same experience. You needed to be in the code in order to be able to do that. And I could see the design, I could see some of the issues with it. And I really wanted to be able to make a difference from that perspective. So I think we talked about breadth and depth in customer operations engineering. I think it's good if you're going to do that to keep a tab on yourself and just see if you're still getting that breadth. And I try and do myself a quick review every couple of months or so and see whether I'm meeting the goals that I set for the last couple of months and things like that. And that's what I discovered. I found that I was narrowing in focus, but I was enjoying being narrowed in focus. And at that point, it's time to look for engineering roles.
And did that engineering, to be clear, that engineering role continued into the replication?
Yes. So,
okay.
Again, touching on what we were talking about before, Confluent had a replicator team that was based in San Francisco, based in Mountain View. and completely, totally open to remote roles. It's one
Okay.
company that did that aspect of things very, very, very well. So I joined that replicator team at a point where they were building it out for managed services, things like Confluent Cloud. Um, and it was really, really great timing because it was a new team built of very, very talented software engineers, but none really that had the depth of experience with the product itself that I did. So I was able to add value in from day one, just from that, and also learn a lot because I was working with, as you know from Confluent, some of the best software engineers in the world.
They were very good. I have a question that is probably pretty controversial, and that is, I believe that most people don't understand that at its core, Confluent's business model is around the replication, and most people don't understand it to that level of why do you use Kafka from Confluent versus why do you use Kafka from other people? It's because of the replicator. So that gets me to my question, and that is, this should be open source. Why is it not open source?
Ooh. So I like to say has been discussed and was discussed many times on the team. So yeah, to put some more detail onto that, I know for a fact that like Replicator was top three revenue generating product within Confluent. The days where people had one Kafka cluster were very short. Like, very, yeah, we, we saw sort of, I think it was less than 2 years of people having one centralized large Kafka cluster. Very, very soon they had team Kafka clusters, they had geographical Kafka clusters, and then replication became a core component. As for why it's not open sourced, I can give you the party line, which was Mirror Maker already exists and is open source. And when Mirror Maker 2 came, it's pretty close in functionality to the way in which Replicator works as well. Close enough, in fact, to cause some headaches inside Confluent. So,
But it's
um,
not broker level, and that's the key. Mirror Maker is still not broker level.
so now this is where it gets interesting because this is carrying on to my engineering. Replicator itself also wasn't broker level; it was a connector, and it ran. But pretty soon after I joined that Replicator team, we began working on cluster linking. Uh, and cluster linking is that forward approach.
And is that out or is that still
Yeah,
in?
cluster linking is out. It is a proprietary Confluent feature, and you need at least one end of the link to be a Confluent cluster. I think the other end can be an Apache cluster. It's been a long time since I've worked on it, but that was the broker level fetch. So that was a very interesting new approach. So that was my second real deep dive into the core Scala area of Kafka. I spent a lot of time working around the edge. I like to think of Kafka as like technology, the programming language onion, right? You have the core Scala in the middle, and that is your lightning fast Kafka code, the stuff that you should really think carefully about touching. And then you have the Java area, which is the clients, the connectors, and things like that. That's the stuff you have to be less worried about, and we can be more flexible with. So cluster linking was my second real deep dive into this Scala onion in the middle, and very, very interesting. So, quick overview of what cluster linking does. It treats it within Kafka. You have your replicas on your separate Kafka nodes. What cluster linking allowed you to do was treat an extra cluster, a second Kafka cluster, as if it was one of these replicas. So it became a very interesting project. And I was there right from the design stage all the way through to implementation and pushing out that. So awesome process to be part of.
So I have another question around this, and that is one of the issues I'm seeing with Kafka now is Kafka was never thought of in the way that it's being used now. I mean, we were talking about SSL. That's a relatively trivial thing, relatively trivial add-on. But the latest add-ons that they're talking about, for example, queuing, I just don't think that Kafka was even with my significant changes, Kafka will be able to do that. What is your take on that?
Yeah, I'm with you, to be honest. I think Kafka is very, very good at doing what it does. Um, I, given what I do for a living, I think the expansion into analytical cases is interesting and does actually work. As a, I don't know that there's necessarily a need um, for the sort of the more traditional MQ aspects to be applied to Kafka.
Well, I think there is because if you watch, I did an analysis and I did a post talking about this. Even during their keynote at the last current, there were two people talking about queuing, where they use Kafka for it. And I was thinking, how did you use queuing? It's not built into Kafka. You either did the crappy implementation that I've seen with lots of workarounds. Uh, it was kind of weird, but I think that we actually have more queuing than we'd like to say. Or well, you were dealing with end customers. You'd probably know just as much of why did you put that workaround in? You're trying to do a workaround with queuing. Is that what you saw as well?
Oh yeah, definitely. Yeah. And a certain amount was integration with legacy, which didn't go well. I mean, you got to remember this is. I'm trying to think back. This would be the third iteration of queuing. Would it be in Kafka? We did have connectors, a connector-based approach that I believe would cache and serve. I can't even remember how it works. I think it's still there, but it's exciting. Actually, sorry, you just piqued one thing I did want to talk about in queuing. The one thing that definitely needs to happen to Kafka, and I believe will probably happen to Kafka in 2024, is the partition will no longer be the smallest unit of concurrency. Now, there's already the concurrent consumer, which kind of goes some way towards this, but I think, and queuing also looks at this in a slightly different way, as the the partitions now are it's too large uh, um, as a unit, right? And it doesn't provide really the access patterns that we're going to start seeing within Kafka. I actually have an old design of Streambased where I started using the individual segments, the files themselves, as the units of concurrency. And I was able to achieve some really interesting things. We canned it in the end because you need access to the file system to use it. And so it's not really a great proposal for a managed service or something like that. But this concept of a partition as the smallest unit is starting to cause pain and it's very breakable. Right? So I think we'll start seeing some investigations in that area.
So the just in case people aren't following what we're talking about, let me explain what we're talking. In Kafka, when you consume something, you no matter what, you don't get outside of a partition. So as much as you've seen some key based or something like that, what's happening behind the scenes is all of those partitions are heading in. It's not being separated out by the broker. If you were to look at something like Pulsar, for example, Pulsar is actually can be broken down for even more than a partition. So when you receive a key in Pulsar, it is just that key, not here's the entire partition with the consumer breaking it down by key by itself. And Tom concurs. Okay, good.
Yeah, right.
So let's move on to your next place at Conduktor. I won't go deeply into Conduktor because I just if I interviewed Stefan about Conduktor, but let me ask you, what did you find interesting about working at Conduktor?
Sure. So Conductor was a great experience and amazing prep for what came next, to be honest. So for those that don't know about Conductor, there's really two products that it offers today. A best of breed UI products, and if you work with Kafka and haven't tried the Conductor UI, definitely go and try it because it's by far the best one I've ever used. It's brilliant. But
And
what
that
they were
includes
finding,
the Confluent Control Center. Is that correct?
yes. Well, that's kind of I will. I don't think you need any more detail on that, but yes, it does.
Okay.
uh, so, what was interesting about Conduktor is they had this fantastic UI product, but it was starting to see competition from open source and free products, right? But in my opinion, it's only my opinion, weren't as good. But as a value proposition, free and open source versus proprietary and commercial, you could see that as a kind of competitive thing. So they were investigating ways of expanding their product set. So what I joined Conductors to do was essentially become a bit of a startup within a startup. So I joined Conductor to build their gateway product. And gateway, for anybody that doesn't know, is a Kafka proxy. And that's my other prediction for 2024 in Kafka, by the way. We're going to see a lot more proxies. I'm amazed we haven't seen it yet. But what happens with a proxy is we take the core Kafka, we decide it's missing a feature that we desperately want, and so we realize it through that feature through a proxy. I think Stefan did some examples with you in terms of encryption, data masking. All of these are features that you would expect to see in a best of breed data platform, really, but are missing from Kafka.
That is the nicest way I've ever heard that be said. It's missing in a best of breed rather than should have been in there. Why is it in there? I mean, there's a blog post that I wrote about it where I said, given the sheer amount of investment in Kafka, how can this not exist? I don't understand it. I don't remember the number off the top of my head, but I actually called out Confluent's engineering spend per year was something like 200 million or something crazy. I don't understand it. I honest, not just let's say somebody's watching this as a Confluent investor, they should also be asking this question because these are things to you and I that are just clear as day. Why does this not exist? This should be like this should have been not just current product. This was stuff that should have been in there 5 years ago, 4 years ago. It's blowing my mind. Or even with Stefan, some of the things we're talking about, we had the same thing of here's an entire company that's just doing it because for some reason it isn't being done. It blows my mind, frankly.
I mean, yeah. And maybe this is only a personal theory of mine, but does it hark back to the fact that it's an open source product? Maybe there's that attitude of this should be fixed in the open source. This is not a job of the proprietary users of Kafka to fix. Maybe is that something you see in other projects?
Well, I think it would coming at it from a Cloudera, since both you and I are coming at it from the Cloudera point of view. I think that we would have said, yes, this belongs in the open source. This is something that the open source community would benefit from. I don't remember there really being a debate in there of, hey, we shouldn't do something because we need to keep this proprietary. I mean, yeah, it's kind of weird to me.
Do you think there's kind of an attitude where you can say there's a thriving Kafka open source community? Why should I be dedicating my engineers to doing this kind of stuff? Somebody else could be doing it.
Well, that's what I don't know is could you say it's thriving? Like how many non-Confluent, non-Conductor open source contributions are there to Kafka? I don't know. I honestly don't know.
I actually think that's getting very exciting recently. The Confluent focus on Cora rather than Kafka is actually, in some ways, I think it's left the open source project up for grabs. So we're seeing Avon in particular, like really exciting contributions from Avon and Uber and things like that, to a level that I definitely think what you were talking about was happening a year or two ago. But I think now we're seeing it move out from being another arm of Confluent to being the true open source project. And it's you look at some of the kits that have gone in recently. There's a kit for open source cluster linking. There's actually a kit for what I call heterogeneous replicas, for having sourcing data from Parquet rather than from Kafka log format. these are exciting things that don't hold, in my opinion, much of a prospect for Confluent. So I think the open source community in Kafka is starting to really thrive again.
That's interesting. I haven't heard that before. Thank you for bringing that up. So the other question to that is, geez, blanked on the question I was going to ask. That's what it was. It was around, okay, so at let's not, I won't name the project, but there's another project out there where it is a single company driven, and the entire PMC for it is a single company, and any contributions are going to get blocked by that company because they don't align to that company's what that company wants, let's just say. Is that happening within the Kafka community where we'll get all these kips, we'll get all this effort put in, and they'll say, nah, that that will cost us money.
I don't know. I don't. I don't know. I have heard stories of that kind of thing happening in the past. I don't know of any concrete cases of it happening, but I think if you say Confluent were this proprietary de facto owner, right, I think what they've done really well recently is relinquish those reins. So if it did happen, it's not happening now.
Oh, that story I was saying wasn't, that was a different project. This wasn't
Yeah.
Kafka. This is something different.
But
But
but it's
I,
definitely become a feature of open source projects in general, right? We can,
yeah.
I'm sure both of us can count off on our fingers projects where we know that is happening and where we know it's in. And I don't approve of it to be honest, but I can see like um, there's the evangelists of open source, and I'm not one of them, right? Who say everything should be open source, everybody should do everything for the good of the universe, right? We we're here to make money, right? We have to live and we have to have our companies survive. And a lot of the time, a huge amount of engineering investment has gone into some kind of proprietary feature, and you don't really want to see that taken away from taken away with a lower quality feature implemented in the open source. We discussed open sourcing Streambased. In fact, we continue to discuss open sourcing Streambased many times, and we're deciding against it because we are here to get traction, right? And we aren't here for other people to add things. We want to be the ones to steward the streaming data lake. And selfish thing, yeah, sure, but we want to be the ones to do that, and we think we're best placed to do it. So we're not going to enter the open source arena today. Doesn't mean we won't do it when we think when the community's built and we think the time is right. But we don't want to be one of these projects like you were saying, where there's one owner, one member of the PNC, and that's all we're doing.
Yeah, there's a lot to be said. So even other companies I've talked to where they've said, well, the open source, the Apache Foundation model is actually inhibiting early on progress, where you have to do this. There's this standardized way, and that you maybe it's better that you do that later down the road. There's nothing that precludes you from doing that down the road. But you also brought up one thing I want to circle back around on is you think that 2024 is going to be the year of proxies for Kafka. Why do you say that?
Um, because I think we're right for it. Um, the customers are asking for it. I know that from my personal experience. And the nature of Kafka is changing. Streambased is one example of that. Kafka is changing uh, much less of an operational focus and much more of an analytical focus. And as you say, once we put these analytical focuses on it, it requires these kind of features. And and proxies are by far the best way to achieve them. To finish the story on Conduktor, the kind of examples that we mentioned, the encryption, the data masking, relatively easy to do. Right? We got those across the line and we got them mature fairly early on in the process. And then we started thinking about what else we can do. And this is where proxies in 2024 become amazingly powerful. Gateway's not the only one, by the way. Gunnar started an amazing project called Proxylicious that you should check out, which is an open source proxy project. And I think there's a Confluent one as well. So there's a few to check out, and I encourage you to check them all out. But What it does is it decouples the physical representation of a Kafka cluster from the logical representation. One of the coolest things we did in Conduktor was a feature we called merge clusters, where you'd have a proxy that sat there and represented a logical single Kafka cluster. But how that Kafka cluster was built on the back end could be in any way. So we had any number of Kafka clusters in the back end, any portion of them set up and represented as a single Kafka cluster.
And if anybody's watching this who's a Confluent investor or something like that, you want to know what the biggest existential threat to Confluent is. It is this. It is proxying, because proxy then makes, doesn't matter whether I'm behind MSK or I'm behind Confluent Cloud. They're now cattle. They're now whatever you want them. And this is, since both you and I were at Cloudera, this is the existential threat that happened to Cloudera, is the commoditization of the Hadoop cluster. It went from pet, which is what you dealt with. There was this 50 node cluster that was up all the time, that if it went down, things went terrible, to, okay, cluster's down, I'm just going to rebuild it and start it up in my cloud, and I don't need to call Cloudera. And that was a huge change.
The other thing it does for the Kafka world is address the replication problem, right? Why replicate if you can pull from multiple? A lot of the replication cases I used to deal with were about assembling data in the right place, and if you can assemble that in a logical way rather than a physical way, makes life a lot easier.
Well,
I
good.
don't know what. Haven't caught up with Steph recently to find out what state that's in, but that was the most exciting thing I worked out in that Conduktor, and it actually powered. We launched it as a managed service. We were able to combine multiple logical topics onto a single physical topic, and launched what we called Conduktor Playground, which was like, log in, have a Kafka cluster. There's no promise on performance whatsoever, but you can create thousands of topics. Why not? Because on the back end, it was a single topic or a small group of topics, but on the front end, it was represented as many. Super exciting tech. We're going to see a lot more of it in 2024, and it's very complementary to what we do at Streambased.
Here we are in the whiteboard. Let's talk about what Streambased is.
So my CMO is going to hate me for saying this, but Streambased is a reaction. Streambased is a reaction to KIP 405 and KIP 833 in Kafka. So what KIP 405 did was allow you to have your, in fact, let's draw it out. It's easier. So today in Kafka, this is what you have. You have your log, and you're going to limit this to around 7 days. And the reason you're going to do that is because this is on expensive disk. And this has been the way Kafka has worked since its inception. You're looking at a short-term buffer of data because your data has to sit on expensive disk. Now, what KIP 405 allowed you to do was take the older set of that data, put it in something like S3. So what we can do, this is a huge oversimplification of a large KIP, by the way. So please go and read KIP 405. This is just massively oversimplified. So what might happen here is this section of the log that's stored up in S3 starts at 7 days and goes and runs to infinity. Why not? Okay, so with this part of Kafka, we suddenly have what we did at Streambased was we took a look at this diagram. We took a look at the capabilities of KIP 405, and we thought, well, what have we got here? We got a bunch of raw data, and we got a bunch of historical data. So what does that equal? It becomes a data lake. That is the widely accepted definition of what a data lake is: a large store of raw and historical data. So at this point, we gathered around and went, okay, Kafka's now a data lake. Everybody's going to come along. They're going to switch on a toggle to say we're going to store unlimited amounts of events from Kafka, and they're going to set be there. But how do we access them? So any kind of ad hoc query that needs to happen, I'm going to give myself a little client here, that needs to happen to access this data and to get some kind of useful analytical use case out of it, needs to do this. It needs to go all the way over here, and it needs to start at the beginning. Oh, I'm losing you because I've got this side, but yeah, you can see. It starts at the beginning. It's going to have to read all of this historical data from start to finish. Then it's going to have to come over here and read all of this later data, and then return back to your client. And this is just not practical for an interactive solution. Right? Depending on the size of the data sets and the queries that we're doing, this could, I've dealt with people that are running Kafka Streams apps that need to restore state stores and things like that, which is the same process as this, and it can take hours. We're on like 7-8 hours in order to restore and get back to input. So our insight was that this isn't practical at all, but the principle behind it of querying this data in an analytical way is powerful, very powerful. If you imagine that, let's jump straight to our end game. Right? Everybody is storing everything that comes through Kafka in their business. And as a side note, because we're in Tom's dream world where everything's wonderful, everybody is using a completely microservices architecture so that all these services are exchanging data through Kafka. And what you have here is a complete change log of every event that's ever happened in your business. An incredible analytical tool. So what we did at Streambased was we just brought 20, 30-year-old analytical technology in order to accelerate the performance of that read from Kafka so that you can use it for analytical cases. We take one of the simplest ones, right? We had some indexes. We had some indexes on blocks of data within Kafka. Let's say we're looking for the name Alice. We could just, we are offer indexes that say no Alice. We use Al, no Alice. No Alice in the so in these blocks, there's no Alice at all. Right now, when my query comes along, it knows, oh, I don't need to read any of that. I can just skip straight down here and go nice and fast and interactive.
Are these indexes via Bloom filters?
Kind of. They're via succinct range filters, which are kind of like it came out of Carnegie Mellon. It's a bit like a Bloom filter, but it's a bit it handles ranges a bit better than Bloom's. Bloom filters you can only really ask for a key, whereas these range filters we can ask for a much more flexible set of queries.
So that would be key plus time or something like that?
Sorry?
It would be key plus time or?
Yeah.
Okay.
Similar sort of. And this
and
is,
sorry, those people watching, if you want to learn something really cool, Bloom filters are super interesting. Not generally applicable all the time, but super interesting nonetheless.
Yeah. They're very, yeah. And we have a number of techniques. So this is just the simplest to illustrate because people are used to indexes and used to blocks and things like that. So it's a number of our core value add is taking the principles that you would normally apply in your separate data lake in your Hadoop cluster or something like that, and applying them to the data at its source in Kafka. So I don't know how to erase this completely.
No, don't erase it. You just have to go to a new one. But I want to break down just so that everybody's clear on this. So here, when you're here, this was your original broker. So the original broker, sort of conventional Kafka, is we have a physically attached disk, and on that physically attached disk, we just store all of the data. But there is this KIP that allowed people to start storing that in a different place, in this case S3. And so what Tom is saying is, if now that it's an S3, we're no longer having to reach internally into these disks, we can just read directly from S3. And if we can read from S3, then we have this raw data that is historical in nature that gives us this data lake. And that is super interesting because, as he pointed out right here, we can have infinite retention of this. And more importantly, we also get the state transitions, which could be even more interesting. Did I do a good summary there, Tom?
Nailed it. I'll record it and we'll use that on our website. Thanks.
No, it's already copywritten.
So,
No, that is
and
my
then
superpower, to be able to do that. Uh, okay, so if you go to press the over onto whiteboard 2, and then we have a brand new whiteboard.
right.
These newfangled tools. All right.
So what I
Uh,
want to
Go
so
ahead.
what I want to briefly touch on today is how you'd handle this today, right? Because it that this data lakes are nothing new; they're everywhere. So today you would have your Kafka cluster sat here. You'd have your ELT sat here, and you'd have your separate data lake. Now, this is something that's made me uncomfortable since the Cloudera days. Right? I've always taken the view that the best place for the core data storage is in its point of creation. So what you've created here is the same data set as a topic here and as a table here. And there are three elements that we hit on in order for why not to do this in Streambased. But really, I only want to focus on this is a technical chat, so I really only want to focus on the most technical of these, and that's consistency. Second, you have this kind of arrangement where you have two copies of the data. There is absolutely no guarantee that you can provide that says these two are consistent. It's the two generals problem, right? It is actually physically impossible to ensure that these two are consistent at any given time.
Exactly. But I would say that there's another part to this technically, is that this right here requires operational changes. So whether it's Kafka Connect or something like that, you are also having to operate this thing. So if we can remove these two things, that's a huge technical change too.
Yeah, and a cost saving. And that one, we talked to a lot of people, and particularly Kafka Connect people. In fact, particularly the Kafka Connect HDFS sync. You talk to those people, they're like, "Oh yeah, but it goes wrong all the time," and it does. And it's the operational maintenance of that kind of thing, especially if something changes here. Right? If something changes on the Kafka side, the overhead to apply that on the other side is very, very expensive. What's
Yes.
it? Someone was telling me the other day about a case where they had a field change in their schema, right? It changed from a Boolean field to a long field. I think it was is using marketing campaign change, or sorry, marketing campaign, bad name, I agree, right? Marketing campaign, true or false, changed to marketing campaign, the ID of the marketing campaign they used, right? So this happened fine in the operational system, no trouble, no. Went straight through the ELT without flagging anything, easy. Uh, by the time it landed in the analytical system, I believe they were using some kind of Python decoder. So anything that had a non-zero marketing ID just became true. Suddenly, they only noticed it when their report suddenly showed a huge jump. Things like that. So it's problems like that that you get with these consistency issues. So at Streambased, we want to be able to give you one core data source, and that is your operational cluster, because that's the point of data creation. On top of that, we want to accelerate your analytical access to that data source and do some other things so that you can perform your analytical queries. We're targeting data scientists, data analysts, AI, ML engineers, those kind of guys that want to interact with the data, get a real feel for it, and be able to use it before it's got to the data engineer realm, as you and me would be sat in, right? One of the things we talk to people at trade shows about is you don't know what you don't know. All right, if suddenly a new and very, very important data source appears in your Kafka, you've got to wait till it's flown through this ELT pipeline before you're even aware of it in order to take use of it. There are many, many areas in that, right? So what we do is we bring it straight to the source. So anytime a new topic or a new data set is available in your Kafka, your entire analyst estate has access to it instantly.
Okay. And so would you mind going to 3 and diagram out where Streambased actually sits in this? So give me
Yeah,
some box diagrams.
yeah, sure. So Streambased is two components. There is one, a consumer component sitting here. I call it the indexer, but it's doing a lot more than that. And this is not for interaction with the with your users at all. Right? All this
This is creating that Bloom filter equivalent that we're talking
indeed.
about. Okay.
Bloom filters, statistics, pre-aggregation. This is all happening here. Okay. Then on on the other side, there is the Streambased server. Server because I can't write Streambased. There's the Streambased server, and this is what's interacting with your analysts. It's also interacting with the indexer in order to accelerate the read from Kafka. So the important aspect from a technical perspective is that the Streambased server holds no data. Right? It still queries Kafka for the data. It just enriches those queries with information from the indexer to make sure it's only fetching the right section. So when we talked about segments earlier, an earlier version of Kafka that would, an earlier version of Streambased that would go down to the file system and ignore segments that it wasn't interested in, we've implemented the same kind of thing. It's a consumer that hops over data that's not relevant to it. Okay? So it drastically reduces the read required for Kafka. Again, I'm using only the indexing example. We do slightly more, but the indexing is just the easiest way to explain it. One other key pillar of Streambased that this diagram makes.
Real quick, there a question. So this query this is the end user here. This query, this isn't going over the Kafka API, or is this an RPC? What's happening there?
That's exactly what I was just about to say. So we decided early on, we don't want to create a UI. We want analysts and scientists and everyone to be able to bring the tools and techniques that they're used to working with. I think there's no point in offering a nice, easy alternative to your Snowflake if it's really, really complicated to get it the data from Streambased. So we actually use Trino as our processing engine, and we surface that data via JDBC. And it's very, very simple batch SQL. It's the SQL you're used to. It's not a KSQL. You don't have to read a book before you can run your first query.
I'm sorry. KSQL SQL. What possessed them to do that?
I think it was a confused product, right? They couldn't decide whether it was an easier way to write streams apps or whether it was a way to expose data to analysts. But yes, so this is basic SQL going over JDBC. So you bring your DBT, you bring your Tableau, you bring your superset, just instantly connects in and you have a view over that data.
And then I assume that you're also expecting there to be a schema registry because you're flowing this directly. So I'm just going to draw that in real quick so that people are knowing that we've got that.
Yes, please. And while you're drawing that in, let's think about what that means from a governance perspective, right? What we have is a single schema registry, which means a single schema for the use of this Kafka data, either operationally or analytically. So we could go back to slide 1 and say, look, the consistency problem we had between the schemas, between the data set and the analytical system and the data sets and the operational system that Boolean to long field change that I described can't happen here because we're using the same source of governance for the operational side of your business and the analytical side.
I would say more importantly that if you have any sort of schema validation, that sort of promotion isn't possible because, or yeah, I'm pretty sure that isn't possible for Avro. You could go to a 32-bit to a 64, but you can't go from a bit to 32-bit.
Yeah, don't get me started on avrological types, but yeah.
Yes. Okay. So
So,
yeah,
you mentioned schema validation. Quick plug, another thing that's great for proxies. It's a good place to do it.
yes. And so kind of bridging this diagram and the diagram you had before, where this is able to reach out directly to S3 because um, it's a short circuit read in Kafka. Am I remembering that right?
So we cheat, but not quite. The reason we waited for Kit 405 is we don't have to worry about that. S3. We can just ask Kafka for the data, and Kafka will take care of it.
But it's a short circuit read. Put a different way is if we were to draw out S3 over here. So it is not, the read path is not like this. It is this. Is that correct?
So yes, but it's slightly more complicated. What we do as Streambased server is ask the Kafka cluster for it, and then the Kafka cluster provides it to us. But because of the way the clients are organized, yes, it works out as a short circuit route.
Okay. Just so everybody understands why I was making that clarification on short circuit reads versus direct reads. If you know your HDFS, you know that was an important part of it as well. But the performance difference between reading all the way through Kafka to S3 versus a short circuit read quasi directly to S3 is a big difference. That's a big, especially if you're doing analytics, where if you're trying to do analytics in this read path, that's going to be virtually, I wouldn't say impossible, but it would take quite a while. Simply because your stream-based server can now read directly to S3 and with S3 scaling well. Is that a good summary there?
Yep, sounds great. So but so the key principle is we want to avoid read as much as possible, right? And that's where the indexer comes in.
Yeah. Yeah, that's another important part is reading. You see that pattern in various databases, but yeah, that's interesting that how you're doing that. I find a lot of your architecture ingenious, where you're actually creating this indexer in real time by being a consumer of that, while at the same time reading directly. All very interesting. And I'm just going to write that this was JDBC here.
So
So.
so you can see that I mean I'm going to point out the flaw in the architecture while we're there. So the flaw in the architecture is, if we're completely caught up, and if my analyst only wants to see the latest piece of data, there's no advantage. 'Cause as
Yeah.
you say, there's a consumer for the indexer. It's lagging as much as the read is. So there's no advantage of this case, but that's not the case we're looking for. We're looking for this extension where people have chosen to store their data infinitely. And there's a big long tail of data back. It's kind of another one of those crazy Kafka hasn't had it yet things. It makes perfect sense to be able to optimize those historical reads. And yeah, it hasn't happened yet.
Yeah, and that's part of why people would have seen that Confluent is now investing heavily into Flink, because that case that he was just talking about, that's a case for Flink. You do that real time read in Flink, where I think we're talking about analysis, which is not really what you use Flink for in this case.
Yeah.
Okay.
But what you've a little segue on that one, right? If you take I was talking to people the other day that were saying they have the state stores that go with Flink and go with and the snapshotting that goes with Flink or K streams. They have different versions of how they do this.
Hmm.
I was talking to someone that's saying those stores are in some ways equivalent to the indexer, right? In some ways, that's what they do. They give you a fast read and a fast way to access point data rather than sequential reads, right?
Mhm.
And they were saying that some of their Flink apps were exceeding sort of 300 gigs for a state store. And as well, is that not a database? Have you not created an ETL at this point? And I've actually written a blog post on it. It's quite an interesting way of looking at things, and that Kafka to ETL to store can be quite well hidden. It's like if you have a because if you have a state store or something like that in your stream processing application, that can be considered, and you should consider it as an ETL in some ways because it's a resilient data store in a different format to the way it's in Kafka. Uh,
Yeah.
now that
Or
goes
or
to your
or you're recreating what's over here. If you're at some point, if you're caching everything in Flink, then perhaps you're going about the problem the wrong way. I would say that your state store should be some sort of ongoing equivalent, ongoing count, latest, last message, that sort of thing. But yeah, for historical purposes, this would be this sort of style would be a better route.
and I prefer it because even if you did the state stores wrong, right, and stored all your historical data in it, it's for one application. This is a much more generalized case. We like to tell people that the scope of, as we touched on before, the scope of data that you can look at in Kafka is drastically changed because you are looking at your RBAC or ACLs, one source of uh, authorization governance, right? For operation, the second you're given access to a resource in Kafka, it's available to you in your superset, in your Tableau. It's available for those analytical purposes too.
And I
I
would
think
say
you have to.
even more importantly, without having to do any sort of creation in the back end, it's just immediately there.
Bingo.
So
You look at the same thing for the ETL based solution, you have to do your authorization to fetch the data into ETL. You have to do your authorization to push it into your data store, and then the authorization to be able to give your analyst access to it.
okay.
Most likely in different ways, in different systems, and yeah, all of that stuff.
So let's double click into the Streambased server. And is that what you want to call it, the Streambased server?
Yeah, we'll call it the Streambased server. That sounds good.
Okay. So Streambased server, is this a distributed, I guess what you'd call a consumer group in Kafka, but you probably have a different name for it. So is this able to be distributed?
You've nailed it. It is exactly a consumer group in Kafka. But I'm going to hold my hands up here, yeah, and say what we did was we built a very, very customized consumer that was able to accept extra information from the indexer and able to combine things from disparate sources and things like that. And what we did is we plugged that into Trino. So the majority of the um, data processing and filtering and things like that is accomplished by the Trino engine.
Now, in case people aren't familiar with Trino, give us a little bit about Trino.
So Trino is the open source fork of Presto that was developed in Facebook for the purposes of marrying up disparate data systems. So it would allow you to run queries over the top of your HDFS and join it with your MySQL. And they do have a Kafka plugin. It's a little known fact that it's not very well maintained, but they do have a Kafka plugin for being able to fetch data from Kafka. Now, we've added some extra features to that. It was missing some Kafka features that means it won't work with things like managed services, for instance. But we've added we've taken away some of the barriers to that. And then we've put our acceleration technology into the Kafka layer.
Into the Kafka layer, you said? Or into the
Yeah.
Trino layer?
Well, into Trino's Kafka layer.
Okay, okay.
Right. Yeah.
What that meant was this Trino based streaming server needs to be able to understand not just the S3 but also the various indexes that the
Yes.
indexer is laying down, and so this indexer, it's laying those down into the S3, or where's the actual indexing being stored?
So you have some options. There's a basic in memory option. The most common one is laying it down into Kafka. We know we've got a Kafka. We know that's a safe data store. We know we have access to it. So typically we write them back into Kafka for persistence.
But that'd
And
be
then they are
those would be larger blobs though, and Kafka just isn't as great at that.
they don't necessarily have to be large. There's a gray area, right? How it depends on how big you make your. You can marry up index size versus blob size versus the amount of offsets that they are relevant to. So there is a trade-off there for how you want to do that. It's not one single index over the whole of the Kafka topic, for instance. We break the Kafka topic down into segments of offsets and then add indexing over those.
I see. So on let's say we're the indexer died and we were doing a startup, you would read through that topic, and then but then you get into the same sort of issue of that Kafka Streams has, and that is how long does it take to start up an indexer from cold?
Yeah, indeed. That's why the indexes are resilient. You can have multiple of them and standardized and things like that.
Oh, I see.
Um,
Okay.
yeah,
So the
the,
indexer would be a consumer group as well.
yeah. And what's really nice about Streambased actually is the way in which it degrades in that situation. I've put in some I've put some bad configs in and had my indexer fall over. And the worst thing that happens is you get a slow read out of Kafka. You don't get any failed queries. The performance just drops drastically.
Okay. Oh, yeah, that's a good way to handle that. So part of the reason why I'm asking Tom these sorts of questions is if you're laying distributed systems on top of distributed systems or a non-distributed system, you could have this, oh, this thing scales well, this thing does really well, and then we put on, let's say, an indexer that doesn't scale well, it isn't distributed. But as a true distributed systems engineer, he's thought through all of this.
The last thing I want to do is make any one of these components that is a single bottleneck.
Yeah, a single bottleneck, single point of failure. So great design on that part, great thinking there. So in some ways, each of these boxes would be, the dot 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 box of that we have many running behind the scenes, or n
Exactly.
number running behind the scenes. Okay. Um, let's see. So I think we got that S3, got that. Is there anything else that's part of this path that we haven't discussed?
No, one of the things we were dying absolutely desperate to do was to extremely reduce complexity. And that's why we've gone for a minimum number of components. We've gone for a graceful degradation. These are all like core principles to the way in which we build our analytics software.
Okay, so let's talk about the performance. So here I am. Let's say I'm reading this in, I don't know, superset. What sort of performance would I be getting over a largish topic?
I knew you were going to ask me that. There's lies, damn lies, and performance benchmarks, as we know. So
Hmm.
I will caveat myself with this is entirely dependent on the data set and that you are reading, on the ways in which you've decided to configure your indexer and things like that. But I think we see for, let's say, largest topics. So we're talking several million messages in there, right? And I'm trying to give as many statistics as possible in order to make this a real case for people to reproduce. I think we had a cardinality on those of around about 20,000 odd unique keys with it for the query attribute that we're searching for. Given that kind of scenario, we see a speed up of around sort of 25, 30x versus base read. So, but what I want to make clear that a separate analytical system could probably outperform that. Like an Impala is probably going to outperform this. If you've landed all the data into Parquet and you're querying it with Impala, it's going to outperform that. But what we have done is kept this simple, not complex, and totally consistent system and made it interactive. Right? That is the kind of performance where an analyst can come along and in real human time run their query, expect to see a result, and expect to move on with their day. Versus the old way where we like to, when we talk about performance benchmarks against traditional analytical systems, we always like to include not only the time it took to get from Kafka into that analytical system, but the time it took to build the pipeline and maintain it going forward and things like that. So in that case, we're competing in terms of days. So it's very, very much more performant.
Okay. So this performance makes sense. The other thing I would say is some of this is what people were trying to do with Kafka streams, where they thought, or KSQL DB more correctly, they were thinking, oh, with KSQL DB I could run this historical query, but it was too crappy, very very much too crappy.
It was me. I was trying to do that. Yeah, and well, it goes back to the first slide, right? Every ad hoc KSQL query involved a read from beginning to end. Even if you had even if you had a filter down to a single record, right? It involved a read from beginning to end. So it just wasn't practical as that interactive experience. And that is our goal at Streambased. We don't necessarily want to be the fastest. Obviously, we'd love to be the fastest. But what we want to do is provide that interactive experience for your analyst.
And what you mentioned a bit ago about Parquet, one of the KIPs that's coming out or is being proposed is to start writing this data in S3 and Parquet format. Are you going to be able to take advantage of that?
We will natively via Kafka. However, I'm glad we brought this up because I'm not sure I like that as an idea. Stream Native, by the way, are already doing it in Pulsar. So they already have a much more analytical format. I can't remember which one they chose. And and that is natively sat inside Pulsar. But what we didn't want to do was compromise Kafka in order to gain these analytical capabilities. Now, if you imagine that you have a Parquet replica, right, is never going to be able to satisfy the operational case as well as a Kafka format replica. If it could, we'd already be doing it. So in that standard consumer sequential read case, Parquet is actually going to hurt you because all your topic column or your row columnar stuff and things like that, stitching it back together for individual messages, it's going to hurt you.
Here, would you mind diagramming that out? I know what you're talking about, but I'm wondering if people understand that. So go to 4.
Yeah. So let's take our data set, right? We have name and age, right? In Kafka, every row would be one message. So we have Tom. I'm not telling you how old I am, but we'll say 21. We have Jesse, who is also 21, right? So in Kafka format, a message would be a stripe across this row. And this is the way it's stored on disk, right? Tom, 21, then the next one, then Jesse, 21. The Parquet one is slightly different. I'm putting these horizontal to a row columnar format is different. So we'll look at this. I'm putting these horizontal for a purpose. So it would have stored on disk. It would have all the names, Tom, Jesse, and then all the ages. Oh, it's written age. You get the idea. It's 21, 21. Now, you can imagine that for analytical purposes, when you're most likely going to be filtering by a particular column, so select age from, right? This side is much more performant, right? Because you can have a header at the top of the file that says skip all of this down to where age sits and then read them all at once. That's great. But conversely, when you're using your data for an operational purposes like Kafka does, what you want to do is receive a message with all the detail in it, play it to your downstream system, and then receive the next message with all the detail in it and play it down to your downstream system. For the format on the right to be able to handle that, it has to skip around and stitch a vertical message together from different places in the file. So it's going to hurt you. Now, what Stream Native, and I think I haven't fully read the kit, so on that one, what I think they're proposing for Kafka is that you have, say, two replicas that are in this format, and you have a third replica that's in this format. Now you think from this that you get the best of both worlds, because now you can serve your analytical cases from your row columnar format, and you can serve your operational cases from your standard format, your read top to bottom format. But what you've actually done is introduced a huge performance hit in terms of degradation. So if you lose these two replicas, I don't know how to, let's kill these two. What you're now going to have to do is serve your operational capability from that row column capability, and vice versa, right? So your only option really is to expand the number of replicas, right, on both sides. At which point you may have solved some of the complexity problems because it's all hidden inside your operational system, but you're still having separate copies of this data that must be kept consistent, that are costing you money, that are it's kind of what I was going back to earlier. These ETLs are well hidden, and it might be internal, but have you not just done that?
And created an operational 6x of data, or 3x in this case.
What is interesting, and what I do like about this solution, is that ETL is bidirectional. Right? Well, you can restore one, whichever way you want to go, you can restore one replica from the other, and that's pretty cool. I do really like that as a principle. It's actually something I was discussing with the rest of the customer operations team in Confluent Summit 2018, something like that. They were like, "You're crazy. It's a terrible idea," but I've always liked it. But in terms of benefits that you get from it, we much prefer not to reformat the data. Instead, add metadata that allows you to accelerate it and stuff.
Interesting. Also, I think the question in my mind is, how often do you read this way versus how often would you read this way? As it stands now in a current Kafka cluster, it's 0% this way because that doesn't exist. And I don't think people are really thinking about how you use Kafka, native Kafka, as the backing store for an analytic purpose. So it's 100% this way. If we were to expand this out into this new world, this new Tom world, I don't think that we read historically as much as you think, unless you're doing a backfill of, let's say, your Kafka streams died or something like that. You're trying to rehydrate something like that. It's only in those rehydration periods, and I'm wondering if you could optimize those rehydration periods by reading larger chunks.
Yeah, that's an interesting concept. Just going back to whether you do it for rehydration. There's another aspect of this that definitely not today, because we've only just had the capability to store the raw and historical data. But we see it changing dramatically. Let's take one example that I like to give. It's like an ML flow kind of example. So you need to do some kind of EDA, some kind of exploratory data analysis in order to build a model that you're then going to deploy into microservices to work with your Kafka cluster, right? If you use either this solution or Streambased for that purpose, you're working directly with the data that the model will be working with. Right? And you're doing your analysis, you're doing your training on that data in real time as it's coming in, versus what happens today, which is you dump it over into a database, you put it into a notebook, you start poking around with it, and then you try and work out how to drop it back into Kafka. So that's just one of many cases where we're kind of people are getting this aha moment. They're like, it's the friction between converting between data formats that you're avoiding here. Right? Because I'm using the data as it was native in Kafka, when I drop my model in, it's going to work with that data native in Kafka. It's these extra steps in these pipelines for developing data products, developing machine learning models, developing AI tools that we are able to reduce by using this one single source of operational data. So while I agree that today a lot of it is just rehydrating stores, I think that's changing. That's definitely changing. People are bringing more common and more interactive use cases into Kafka.
Excellent. So, what's exciting you about your roadmap right now?
So I'm just going to break everything I've just said and say what's exciting me is actually I was working on it this morning before we joined in this call. We have a version of row columnar that we're calling partition columnar. And you can probably see where that goes. Where we do the stitching natively in the Kafka consumer, but we just assign the Kafka consumer all the partitions. So let's say you had a partition. How do I get different colors? Let's say you had this was a partition, and this was a partition. Right? Now you could ensure that a consumer was assigned all of those partitions, all the relevant partitions they need to reach the query, and then the consumer can do the stitching back together on read.
It's almost like what HBase was doing with column families.
Yeah, a lot like that. Yeah. Again, this is Streambased is about taking 20-year-old database technology and applying it to event streaming. Like we're not inventing new ways of looking at data. We're just applying old ways to a new source. So the results of this still remain to be proven. But if you can imagine, this is like an order of magnitude speed up again. It's the same bonuses that you get from the row columnar formats. So we're quite excited about that one.
Okay. And since you were working on it this morning, when do you think that'll be released?
Sorry, I have to laugh because based on what I was working on this morning, a long time. But no,
but to your shareholders, it'll be tomorrow. Any VC.
Everything we're talking about internally in Streambased is based on Kafka Summit right now. So expect to see something before Kafka Summit.
Okay.
Which is late March.
Okay. Well, that is startup speed. That's not enterprise speed.
We are definitely startup speed at the moment.
All right, good. Well, let's talk about you a little bit more. Why did you decide to found a company?
So this is obsession. Let's say that's why I decided to found a company. As you can probably tell from our chats up to this point, I have been obsessed with this problem since way back in Cloudera days. I had decided to found a company based on this kind of technology more than 3 years ago, but the timing wasn't right to do it. So we talked about those trigger points for KIP 405 and KIP 833, and I was ready to go. I also think I've gained a lot of experience. I've gone progressively earlier in companies, and this was just a logical next step for me. I don't really think about it as starting a company, to be honest. I think of it as pioneering a piece of technology, and this is just the fact that I'm a big part of the vehicle to do that is great.
That's an interesting way of putting it. Both two parts. Both you were gradually going earlier and earlier, as well as it's the means to an end to get your idea out. I see. Okay. Another question I have, I'm seeing a pattern of a lot of people leaving Confluent and founding a company. Why do you think that is?
So it's kind of we'll cover the easy one first, right? They're capable of doing it. Confluent did very, very well. A lot of these people are financially secure, so they can afford to speculate a little bit. Right? But more than that, I think Confluent was really a great hub of ideas. That's something probably to its detriment, actually. Like, there was a period for around, I think, before things became standardized around Confluent Cloud, there was a period of just go do it. Right? I've got this idea, it might work out, just go do it. And it benefited the company loads in the early stages. Um, and it encouraged that kind of thought processes, that kind of ethos. Most of the people that I know from the Confluent days have these, a bit like me, right? They have these obsessions, they have these bugbears that they've been wanting to get off their chest for a while, and maybe it didn't make sense in to do it in Confluent as a commercial product, and they're off doing it as a company. I think one thing that Confluent really did do well is it was incredibly inspirational in the early days. So it really did encourage you to want to push the boundaries, not just in your day to day, but also in your career as a whole. I
Okay.
don't find it saying.
No, I don't find it odd either. I just, when I was writing that question, I actually reflected on a lot of the early Cloudera people. I don't think they so much founded companies. Um, they probably joined early companies, but I definitely saw that Confluent was more. You had Gwen Shapiro. She started her company. Then you had quite a few. Not that, but Cloudera had some people found their own as well. Okay, so what advice would you give aspiring programmers to get into entrepreneurship?
um, so I'd say it's a bit like having a baby, right? There's always reasons not to do it, and there are always going to be legitimate, good reasons for not doing it. But you've got to just kind of look past that, and just there comes a point where you've just got to jump. I think for certainly the interactions that I had with startup founders before deciding to go ahead. That's a good piece of advice, by the way. There's some great networking meetings and things that you can go to where people are just really, really open and honest about their experiences, and you can get a good idea of what to expect. But I think a lot of these are overly negative, right? Starting a company used to be this, and certainly is to me, this really exciting, really powerful thing to do. And now it's try it next time you see somebody who's thinking of starting a company, right? Or next time you see someone you know very well who's been in the tech game for a while, right? Tell them you're thinking about starting a company. I guarantee the next thing they're going to say is, "Oh, it's so much work. You're not going to sleep for like 3 years. It's very impossible." And 99% of them fail and things like that. I think we need a bit more of an attitude of positivity around it. Yeah, it's a risk, and yeah, you should do your due diligence to make sure that you can stand the risk. Go into it with your eyes open, knowing that everything could go wrong. But also, like, it's the chance to bring your something of yourself to the world. And that should be an exciting thing that's encouraged rather than discouraged. Um, I really like the Californian way of doing it, I have to say. The culture and the attitude in California is very different to the culture and attitude around startups in London. Um,
Or
and
Europe in general, I'd say.
yeah, so I feel like, yeah, oh yeah, I think Europe in general is fair. So I feel like in Europe, it's seen as a way to make money more than a way to influence the universe. I much prefer the influence the universe.
And this entire time we've had your guitar in the background. Tell us about your musical ambitions.
Ambitions is the right word. So yeah, I was a guitarist and keyboard player in my younger days. It's very, very much a personal hobby. I don't think anybody really wants to listen to me play a few blues riffs, which is basically all I do these days. But yeah, it's a way to unwind, and I think it's important to have that. Especially for me, I find it important to have that hands-on thing. I like to be doing something, but not, but be able to switch away from the tech world and be able to switch the computer off and just relax a bit.
Okay. The Kafka Blues. That's what I'd be playing.
The
The
Kafka
Kafka
Blues.
Blues. Well, Tom, thank you so much for being here, sharing so openly. I really appreciate it.
Oh, no worries. It's been an absolute pleasure.